Hello, I think we're live now. How's it going? As usual, just gonna run some audio checks at the start, and then we can get going with today's stream. I can already hear myself. I can already hear myself. It's a nightmare when you can hear yourself, and then you can hear yourself hearing yourself in that stream, and it just keeps going until you stop the stream. But anyway, happy Sunday, everyone, and it's good to be back after I think it's been like a good 5 days since I've not posted anything, and I'm looking to basically write a few good features for the 6502 emulator that we have been working on. Now, let me know if I sound good, if it's too loud, or you guys feel like my voice isn't heard very well. I can always change it. So, what are we doing today? Today, I'm planning to kind of play with C++ concepts. So for those who don't know, C++ 20 introduced the idea of concepts, which is C++ implementation of kind of like traits, right? Traits and interfaces in Golang, for example. So if you've done Rust before, you may know traits. And if you've done Golang before, which I guess a lot of people watching this stream are kind of have tuned in because of Golang, you have interfaces in Golang where you can define a particular interface for a structure, and you can kind of define which methods should be available for a structure to implement a particular interface, right? And this is done, well, this was historically done in C++ with the templates, right? So in C++, you can have templates that you can kind of call arbitrary functions that will be kind of resolved at compile time. But if you also watch the channel for quite a long time, you know that I have a personal problem with C++ errors, and in particular template errors. And one of the annoying ones is when you kind of use a template that doesn't really have a particular function. And the error you get there when you do something like that isn't particularly useful. But with concepts, that should have in theory improved things a little bit, because when you have a class or a structure which doesn't really have the expected methods, then the compiler should be able to give you a nice warning or a nice error. And yeah, this is what we're going to do. So for the research of this video, actually, I was coding for most of the day today, and I've actually implemented this feature already. So the context here is that I wanted to kind of have a way to profile individual functions for my 6502 emulator in a way that I can just kind of add a line at the start of it, and then that would track the amount of time that the function takes, right? So I essentially just wanted to have a particular class where at the start of when you create the profiler class, it will start timing the function, and then when you kind of when you destruct that object, it will save that the measure into a map or I guess a graph structure, whatever you call it. And this is kind of now possible with a few additions of the C++ standard, right? So first of all, we do have this the new header in C++ called, I think it's line source location. Yeah, that's the one. Source location in C++. And for those who have never seen this before, this particular header gives you a bunch of usable functions that you can put in your source code to find information such as the line function, or the line number of the code, of where that line represents in the source code, basically, on which file it is, the column as well, and also like file name and function name, right? So we have a way of kind of getting these values in the C++ standard right now. It was possible before. There was some macros defined that you could call it, but I'm not sure if they were like necessarily portable. But with this header, we have a lot of that functionality added to us and guaranteed by the standard, right? So basically, all I wanted to do is to basically just get the function name of where you're running, and then kind of have a timer running for that function. And whenever we finish it, we're going to say, this function took this many seconds to run, right? So this is the main context here. And I came across the problem where I was using templates across different places, because like I wanted to be able to make my profilers or my profile class very kind of flexible, so we can basically turn this into a library where people can just include in their code and have some sort of like easy to include profiling. And I ended up with this class here. I'm not sure if you guys can see the code very well. I'm going to actually zoom in, where I basically just keep a few things. Like whenever I create the class, I will get the name of I'll get the name of the function that I'm calling the constructor with. And I'm also going to store the time point at which I create that object, right? And in the destructor, you can see here that I do another time point here, and I get a time difference between now and the start, and then just simply save that to what I call it books here. It perhaps should be given a better name, so something like a profile book or something like that. And in fact, I can probably rename the symbol as well, because it's called unit, but really is a function profiler. That's what this class should be called, right? But yeah, I mean, this is the bread and butter. There's nothing too difficult. So basically at the start, at the creation of my object, I start the timer, and then at the end of it, I stop the timer and then save the time taken for the execution into a map or whatever I want to do it. And this is the important part. So I didn't really know where I wanted to save these measures. So initially I did think about a map. Obviously, it's probably the simplest way I can do it. But I wanted to be able to kind of update the profiles in whatever data structure I want. So for example, if I wanted to store it into a JSON file where I have some sort of like a graph structure, so like you can have, function A was called by function B, and etc. I wanted to be able to kind of make that flexible enough so in the future I would be able to do something like that, right? And this is where templates come in, right? Because instead of defining that kind of the type for the books here, I call it books, but really is the profile book, so where I store all the profilers or all the measures. I wanted to just make it as generic as possible, but generic in a way that I can still tell people like what they're missing in the book, right? So I don't want to just call something like template and then update here, because when you don't have that method available to you, then you're going to get a very nasty compilation error. And this is where I thought of using concepts to constrain this particular profile book. And you can kind of see how it's implemented here. We'll talk about this in the future. But first of all, we're going to kind of do something similar in Rust. And I'll basically just teach you guys the idea or how this is implemented in C++ by going from Rust to C++, right? Because Rust actually has type traits, and these are part of the language, or have been part of the language since the start. So it's actually very, very easy to understand. It's very, very ergonomic to use as well. And concepts in C++ are a nice idea, but you can kind of tell that it makes the syntax of the the code a little bit weird, and it's very different to other syntaxes. But in Rust, that's a little bit different, right? So what I wanted to do is basically, can I zoom in here? There you go. You guys can probably see it a little bit better now. So what I wanted to do is I wanted to have a trait for the profiler, and this is basically where we kind of like store or start timer. So we start the timer at the creation, and then we sort of store the time taken. The timer called drop, right? Let's say drop here. And I don't think this is kind of going to work in Rust in the same way as C++, just because drop doesn't really have the same guarantees as it does in C++. Not guarantees, but the same behavior as it has in C++. Because in C++, when you drop an object, or when you create an object at the stack of a function, right? So if you create an object at the very top of your function, that object is only going to be destructed at the end of the function, and that's guaranteed by the standard in a very particular, very defined order. I think it's actually a first in, first out. It might be a stack, I don't know, but all I know is that it's guaranteed by the standard. With Rust, that's not guaranteed. So drop can happen at any time the language kind of decides that the variable that you're you created isn't really going to be used anymore, right? Algovoid, hello Algovoid. It's very nice to see you, man. I didn't really think I was going to get anyone watching me today, so I was just doing this as a tutorial. But if you have any questions, dude, please let me know. Yeah, so, bottom line is that this, although we're implementing this in Rust here, it might not actually work in the same way as it does in C++, just because of the way drop behaves. But the idea was that we have a profiler that, starts the timer at the creation and then kind of saves it at the drop, right? So for that, I want to just basically create a trade, so something like pub trade, and then I have profiler here. And all I want this trade to have is basically to have a function called drop, in which case I can just say that it extends the drop trait here, and that's already included in the standard. And this is Rust's way of doing a destructor, for those who don't know. So Rust's way to do a destructor is for you to inherit, or not inherit, but implement the drop trait, which is part of the standard, right? And this basically means that we know, whenever you implement this, you need to have a function called drop, which takes a, I believe it's a mute self. It has to be a mute here, right? So this is what the drop thing is. But because I want to be able to also, or I want to enforce the creation of this object for the profiler to run, we also need to have something like a function new, which simply is going to create a new object, right? So we are simply going to return a self here, right? So in a nutshell, that's what the profiler is, just a trait that says an object or a structure should have methods to create one and then drop one as well, right? That's all it is. Now, and obviously I want to be able to also have kind of another trait for updating that profiler, right? So I need to also have a function here, which is going to be called update or something like that, right? Update. And this will take a measure. So I don't know what that type that is going to be. Yeah, so it's going to take a function name. And I do apologize, guys. It's like raining like crazy outside. Like, I'm actually kind of glad that I'm inside right now, because it's like torrential rain outside. I'm in the north of England, and we have like a massive thunderstorm at the moment. So if you guys can hear lightning, don't be worried. I'm fine. I'm safe. It's just very bad weather outside. One of the things I'm trying to do as well on stream is I'm trying to speak a little bit slower, because when I watch myself back, I realize that every time I'm talking very, very fast, and it's very hard to follow, even myself sometimes. So Algovoid, since you're watching this, dude, let me know if I'm talking too loud. I don't wanna sound a little bit rumbly, if it makes sense. And yeah, we're gonna have an update there, which is probably going to return some sort of result, right? So either, an OK value or an error value if you fail to record. For that, I can probably use anyhow. So anyhow is a very interesting library if you guys want to work with error types in Rust, because it allows you to kind of cascade error types a little bit nicer than the standard does. It doesn't bother me. I have a mixer. Nice, dude. You have a mixer? Like an audio mixer? Is that what you mean? What kind of mixer do you mean? Anyhow, result, right? So I'm just going to use that type for now, and then that's what we're going to do here. So result of, either okay or not. And that's what our profiler is going to be, right? So this is essentially what we're going to have. Now let me think about this. So if I were to create a structure that will kind of implement this, it will basically look something similar to, I guess, let's start doing that now, right? So let's say we have a pub struct here called function profiler, right? And we're gonna use hash maps to store this, or hash map to store the profiles itself, so the measures. It's gonna be a hash map of a string to some sort of double, right? So F64 we'll probably do in this case. And to implement this trait here in Rust, what you got to do is, like, once you've defined your structure, you need to actually say, I want to implement the profiler for function profiler, sorry. And this is how you implement it. And this lets the compiler tell you whether or not you've actually got all of the expected functions, all of the expected types defined. And at compile time. So it gives you very, very nice errors when you don't have those things. So for example, in this case, you expected, oh, actually we have a function. Oh yeah, so we forgot about this here. So basically we want to have the func name, right? And I guess we also want to have, on top of that, we want to have the measure itself, right? So we want to say, you know, this function took 2 seconds. So we need the function name and also the time taken here for the function. So I forgot about those, which brings us to an extra point here, which is kind of nice in Rust as well. I'll talk about that in a second, which are associated types. So we can have the measure itself here, which is going to be the measure type. And associated types are a way of you telling Rust that a type or a trait needs to have an associated type to it, right? So that may look like this. So this function takes a function name, which is of type func name. I haven't defined that yet, and you can see that, you know, we can't find that type in the scope. That's because we haven't defined it yet. But we also can say the measure takes a kind of generic type called measure. And you can apply constraints to this. You can say that these things should implement traits itself. But, you know, the syntax for that is just to say that we want a func name here. And we also want another type called measure here. So these are kind of arbitrary types that your trait, your type trait, is going to have associated to it, and hence the name associated types. Hello, Morpheus. I like the name, dude. Is that your actual name, or is it just because of Matrix? But anyway, I do love Matrix as well, man. And there's one thing we forgot. When you have associated types, you have to kind of reference it like this. So it's part of this trait itself. So self, in this case, in this context, it references the trait itself, right? And now we get another type, which is the hash map here. We get another error, and this is just because I forgot to use stud collections, I believe, hash map up there. Okay, now you can see the true power of type traits in Rust. So in here, we define the type profiler, which extends the drop type, right? So it should have a drop function. And we told the compiler that the function profiler structure should implement the profiler trait, right? But because we haven't defined those methods, we get very, very nice, and this is the key, we get really, really, really nice compiler errors. It tells you exactly what it is. The compiler knows exactly what you're missing. So for example, the first one we get here is that the trait bound function profiler drop is not satisfied. And that simply means that we haven't got the drop function in here, right? So, and we also don't have the function name and the measure type traits implemented here. So we haven't defined those, and it tells you everything in here, right? With C++, if you're using just templates, just generic templates, where you're just calling an arbitrary function on a template, you will not get this. You will get a very long error, and it will take you quite a long time to figure out what's actually going on. And types in this case is kind of a way to have a contract between the code and the compiler, right? So the compiler kind of looks for a particular thing in a structure that you should have implemented, right? And it's quite nice. I mean, all I have to do now is basically to implement those things. So I have, I guess I can say type func name. Func name, in this case, would be something like a string, right? Is that how I do it? Ooh, I'm not sure if it's an equals here or not. Yeah, so it is an equals. And we do the same thing for the measure as well. So measure in this case is simply going to be a F64. It's not my real name. I guess that, dude. But yeah, welcome to the stream, man. I think it's probably the first time I'm seeing you here, unless you've joined with a different name. But yeah, just enjoy the coding, dude. If you've got any questions, if you want to ask me anything in particular, just drop a message, and I'm happy to reply on the stream. And yeah, so we're just gonna implement everything, right? So let's do that. So we're missing the new function, so we have function new. And it actually has to be a pub function. I'm not sure if I have to decline derive or declare the pub specifier here. I don't think so. But anyway, so we have new and then we return self. And in this case, we're just going to return a profiler with a default here, right, as the map. So something like that. What is it called? Measures, right? So visibility qualifiers are not permitted here. So pub, Now this is interesting. Why is it not letting me do that? I just remove that for now, just for the sake of continuing this. Profiler is not a struct variant or yes. This should be called function profiler, right? And let's make it a little bit prettier by just moving this to the side by 1. Yeah, so we still, like, we've implemented one of them, so we implemented a new one. Now we need the drop and the update function, right? So let's do that as well. So function drop, and I believe it has to take a mute of self here. And this is usually where we would save the measure to the map, right? I'm not going to implement anything here. I'm just going to do a print line. We're saving the measure to the map, right? So this is where we would save that time difference, right? So we can probably implement something like this right now, actually. So let me see. So time points in Rust. I can't remember which particular types I need, but it's in the stud type somewhere. So what I want to do is, like, I want to start a timer whenever I call a function, and I want to end the timer at the end of the function, and then install a difference, and that's basically how much time the function took to run, right? So instant now. So what do you not like about Rust so far, or could it be better? Hello C, welcome to the stream. That's a good question. I don't really know what I don't like about Rust. I guess the main thing I don't like is the syntax can get quite messy. So Rust is extremely explicit, and there are very few things in it that are implicit. So for example, in C++, you have things like implicit conversion between integers. You have, all sorts of conversions that are allowed by the language by default, which kind of make the syntax a little bit easier. You don't have to do like static casting, and you don't have to do conversion inline in the code, so you don't get a compiler error. So, all of these things kind of mean that you might end up with a very long line of Rust code. But at the same time, I understand that those things are necessary, and I kind of enjoy it. But yeah, syntax-wise, not my favorite language, but at the same time, I take that trade-off between safety and syntax all the time, though. 100%, I'll take that trade-off. What about you? What do you dislike about Rust? Have you done any Rust before? I'm actually interested. Do you guys do any Rust at all? Is this like your first time seeing someone programming Rust? I guess it's not really a new language anymore, but there are very, very few programmers actually doing Rust, and you can see that kind of reflected in the job market. So if you go on LinkedIn, for example, all of you should have a LinkedIn, by the way. If you're a software developer, you should have a LinkedIn. And you search for Rust jobs, there are very, very few of them compared to any other language out there, which kind of means that there's less developers in it, right? So, well, it's interesting to know what everyone's kind of level on Rust is. But yeah. I'm going to actually drop this. I don't want to have a drop there because I realize that this is not going to work, because drop in Rust technically is a destructor. So you can think of it as a destructor in Rust. However, the ordering of destructing in Rust is not the same as C++. As I explained, if you create a variable at the top of your function, the variable might get dropped before the end of the function. It's not, the language is not going to wait until the end to actually drop that value, right? So for that reason, we can't really rely on drop working here. So what we can do instead is basically just define a new function, which will be just the update. That's all we need. So update there. I guess, right? Yeah. And we're going to keep that as is for now. But yeah, in this case, I don't want this anymore, but I do want that function called update, which takes, what was it? Takes the function name as the self func name here. And we also have something like the measure, right? So measure is going to be the measure type. And that's it. And this is where we kind of update the map, right? So we kind of do something like measures. Do we have IntelliSense here on the Rust playground? We don't have IntelliSense. But I believe we can use a get, and we can do get mute, I believe. Yeah, get mute. So previous value. So this is the previous measure or a previous measure of time for a particular function. Because this map measures in this function pointer struct actually contains a map which stores the function name and the number of time or the amount of time it has taken so far, right? So that's what we have here. So we can get a mute on the func name, I guess. And I guess we can do a match here, so we can say, or in fact, we'll do an if let. So if let, that's something that's kind of different in in Rust and C++. We don't have an if let, for example, and I can explain to you what that is. What do you think about package managers for C++, VC Conan, etc.? I like them. I kind of like them. I use them all the time. In fact, I'm a very kind of strong advocate for Conan. I don't know why. Conan is just my favorite one, even though it seems to be more complicated than VC package. But I do like them. I think they make your life a lot easier. Because if you're not using a package manager, you're going to be writing a lot of like extra CMake at the very least to include a system package. Or if you're going the hard way, you're going to be writing a lot of like infrastructure code just to pull dependencies and kind of make sure that the headers are in the right place and the libraries are in the right place to be linked as well. And it just makes life a lot more difficult, but it's not the end of the world. I mean, I come from a background where in my first job of doing C++, and this is a true story, by the way, my very first task was to upgrade one of the, I think it was the zlib or something like that, where we had this kind of code base that had literally quite a few lines of code in it. I think it was like 2 million lines of code or something, and zlib was used everywhere in it, right? And to make things even worse, we had our own version of zlib, our own fork of it, where we changed some of the macro names because they collided with some of the other macro names that we had in the code base. So to me, it was a very, very painful experience to kind of download the new version of zlib locally, make sure that all of the fork changes that we have are actually present in the new version as well, and also making sure that all the new headers, all the new libraries were kind of included in the right places in Visual Studio. And yeah, dude, I mean, that's when I realized that C++ is actually quite painful if you're working with external packages. Most jobs will be C++. I think companies don't want to invest the time and resources of rewriting their C++ to Rust. I agree with that. I mainly see Rust jobs for crypto, but I'm not sure about crypto. Yeah, so see, that's a good point, dude. Because I when I was looking at Rust jobs, most of them were in crypto companies, and I guess crypto companies are kind of new, right? So, you're not going to find many 20-year-old Rust companies out there, just because not Rust companies, but crypto companies out there, because it just wasn't a buzzword back in the day. Although crypto's been a thing for a long time, blockchains have been a thing for a long time. It just recently caught on, so it gives them the opportunity to actually use a new language which is actually safe and performant, which is Rust. And yeah, I guess that's why you see a lot of jobs in crypto in that area. But yeah, I mean, I 100% agree that if I've got a company and my whole code base is in C++, I'm not going to rewrite everything in there. Maybe I'll do new things in Rust, but there's no way I'm going to rewrite everything in it, just because, if you think about bugs and safety, most of the bugs that you see in software are actually new bugs, right? So you have more chances of writing a bug when you write new code than an old code that's been there for 10 years. That's what I'm trying to say here. I looked into Rust, but it seems it has a very steep learning curve, especially with strict syntax. I did C++ a bit years ago, and now I'm back to it. Oh, that's very nice, Algovoid. The thing with Rust, yes, it does have a very, I guess, intriguing syntax. It can be complicated sometimes. In most cases, it's not that complicated if you're doing something simple. But the thing with Rust is that the compiler actually helps you quite a lot. So all that we're doing here, we're getting errors all the time, but we know exactly what these errors are because the compiler gives you exactly what you should do to solve something, right? So, although it does have a steep learning curve, it's actually very easy for you to go from C++ or JavaScript or Golang into Rust, just because you already know how to code and you can trust the compiler to give you like nice diagnostics, right? I'll go void again. I think I will try Rust when I reach intermediate advanced level in C++. Yeah, I think that's a good idea. I always recommend people to start with like either C or C++, just because it teaches you how I guess programming actually works, right? Because you're talking directly to the hardware. Excuse me. I've got a burp here. You're talking directly to the hardware in those languages, and you're actually accessing memory in a way that you can kind of like in your head compile it to binary straight away. So if you know how like low level works, you have a pretty good idea of how these high level languages manage memory and what kind of tricks they use to create something like a vector in JavaScript or whatever. So you kind of have the mental model of the hardware, which is very useful indeed. Brock Daniel, hello dude, hello. It's good to see you again. Sorry guys, there's a lot of messages today. I'm trying to read all of them. Have you done web development before? I've done some web development before, especially back-end development. Front-end, not too much though. I'm not a very good front-end designer, but I have done some of it. I'm, my forte is in back-end development or web development in general. I'm actually quite bad at that. So compared to any kind of reasonable web developer out there, I'm kind of trash. My strength lies in like systems programming. But anyway, let's actually continue with what you had here. So yeah, so we're going to use an if let in this case because we want to check, because this value here can either, in Rust, when you get something from a map or a hash map, this is actually, I believe it's an option, right? With a value in it. And an option can either be two values. So it can be none or I think it's, I can't really, oh gosh, what's it? Is it value? No, it can be, it's sum. Yeah, that's the one. So it's either none or some value, right? So if, for example, this map contained that function name already, we're going to get a value here in the form of some value. If we don't have that value in the map, we're going to get a none, right? So if we have a value, so if we do if let sum equals previous measure equals the previous value. So this in Rust is a very nice way of kind of deconstructing this optional here, because if let will basically do two things at the same time. It will match the optional value. So in Rust we have match, which is kind of like a switch case, really. That's the way you can think about it. And you can also add a conditional here, right? So you can also add a check that is not null at the same time. So it's just syntactic sugar in Rust, and that's what it's used for. But if we do have a previous measure, what we do want to say is like we're gonna do this. So previous measure, we're gonna add whatever the measure is, right? So, and that kind of means that my measure has to, I believe it has to add or something like that. So we have to be able to add measures together, right? Which means we need to constrain the measure type in a way that you guarantee to the compiler that those two values can be added. So I can't remember which arithmetic trait it is in Rust, but I'm pretty sure it's just add as to the operations. There you go. Because this is how we're gonna have to constrain the type itself. So it's in stud ops add, right? And in this case, we can do stud ops operations ops add. Yeah. So okay. In this case, we don't find measure in the scope. Why not? Oh yeah, measures. That's right, because it's self measures. There you go, self measures. Way more flexible. Yeah, so Brock Daniel, I do agree. Yeah, Rust is way more flexible than C++ is. Oh no, which one are you talking about? If you're talking about traits and the flexibility of traits compared to C++ concepts, then I agree. But if you're talking about the language syntax, I don't know. I feel like Rust is kind of more strict than C++, so not as flexible as C++ is. This comes down to things like what the compiler pattern matching. That's the one, yeah. Yeah, so it's way more flexible than C++. I agree, yeah, this thing here. So expect the value found module self. What are we doing here? Yeah, so by answering all the questions and reading the messages, I'm also kind of losing my process thought here. So every time I have to stare back at the code, it's kind of difficult to figure out what I'm trying to do. But yeah, we're good. So func name, update self. Right. There you go. Update has incompatible type trade. What is that? Yeah, this is what I mean. So like, Rust is kind of nice. Well, the compiler in Rust is nice compared to C++. Because we get messages like this. So we're saying that the method update has an incompatible type trade, and all we're missing here is the result. That's all, right? Which means that eventually we should probably return something here that is a result, something like okay, right? And then we have a type mismatch. So functions expected, yeah. So in this case, we just gotta take the reference here. And this cannot be applied to mute F64. Like, why not? Why can't it be applied to mute X64? What if I do that? There you go. That works better. It's just a dereference there. So the idea is that this function, whenever we call update for a particular function here, we're going to be updating the previous profile time by just adding however much time that the function took to execute just now, right? So we're just going to be adding it every time. So it's going to be a cumulative profiling, if it makes sense. So you get the overall amount of time a particular function took at the, I guess, at the runtime of your program. But there is one thing. So one thing I haven't done it yet. So if we haven't found the value, so if we didn't have a previous value, what we're going to have to do is like, we're going to have to add the measures into it, right? So func name measure, just as easy as that. And it should still, I'm trying to save the, I'm trying to save this, but like it's Control S doesn't work here because I'm on the Rust playground. It's just giving me an option to save the file. It's extremely hot. So like I've got two problems here today with the weather. Number one is that it's raining like crazy every now and then. So it actually stopped now. You guys probably can't hear the lightning anymore. Number two is that it's actually quite hot. So here in the UK, it's not usually this hot. It's probably what, 20 degrees now or something. And it's gone from like very, very cold to from a few days ago to very, very hot. Well, relative to the UK, I guess. Which means you start like, you sit on your chair and you're sweating after 10 minutes of coding, which is not ideal. Especially when you have to sit in front of your computer for 8 hours a day, which will be me tomorrow. But yeah. So I'm interested now. So like when you guys, I'm not sure where you guys are all from. I'm guessing some of you are from America, some of you are from Europe. What do you do when it's too hot? So like, do you just sit in front of your computer? Because I nearly die, man. I die every time I have to sweat here through work, and it's not pleasant. I'll tell you that. It's not really pleasant. And I wish air conditioning was more popular in the UK, so I wish I had air conditioners here in my flat, but unfortunately I don't. And I'll tell you what, I went to Brazil last year because I wanted to visit family, and I actually worked for 2 weeks in Brazil, and it was extremely hot, and it was not half as bad as it is in the UK now in terms of just being able to sit down on your chair and actually work, just because we have air conditioning there. And yeah, I mean it gets painful. It's very painful. But this update function should be done now, so we basically have an implementation of the profiler for the function profiler, right? So that's what we have here. I use the fan. Yeah, Morpheus. I mean, I have a fan as well, but it's, I mean, my partner is using it now, so I can't really use it. Can't take away from her. Brock Daniel, air conditioning or you're dead here. Yeah, dude, I mean, I kind of feel like dying here too, but the thing is, with the UK, I mean, it's only ever warm for like maybe 2 or 3 weeks in a year, so it doesn't justify buying and installing air conditioning everywhere, just because it's, you know, it's quite expensive to run them. It's quite expensive to install them, especially if you have like a block of flats like this one where you have to install infrastructure as well. I'm not even sure if it's possible. But yeah, I guess that's why air conditioning is not too popular in the UK. So I'm guessing you guys are in America then, right? Yeah, so we can potentially kind of use that. Wait, what's the mismatch type? It will tell you here. So function name, right? So in this case, we should have done that. Cannot assign to data in an index hash map. Use get mute or something like that. So self is mutable, right? Or insert. Yeah, let's do an insert. Just using the wrong method in this case. Insert, and I guess we're gonna go for func name here and measure. Let's try that. Yeah, that builds now, which is good. So for the testing, let's create a function here that where we just kind of, I guess we kind of just mess about with a weight or something like that, just to see if it profiles things right. One thing I haven't done yet, you might have noticed, I don't have any way to say how long the function takes yet. I don't actually have any timing in this at all. So that's what we're going to have to do here. But yeah, he reaches 50 Celsius peak in summer here where I live. The AC sometimes will be on for a straight week non-stop. I live in Tunisia, by the way. It's kind of hot today, around 30 Celsius. Dude, 50 Celsius is crazy. That's more than Brazil. I thought Brazil was bad already. And, you know, the worst it gets in there is about, I guess, if you're on a bad day, like 42 degrees Celsius. But 50 degrees, man, you're boiling. You must be boiling. Especially like, you know, next to a computer as well. I can't imagine myself doing that, man. I feel sorry for you, my man. That's all I can say. I feel sorry. Yeah, so that's what we're going to look at next, right? So we're going to look at the stud time instant here, which gets the current time point. So duration new, instant now. Time duration instant, right? So we have to use something from the standard. So use std time instant, I believe it is. And I guess we can have something like, let's make it public there. And also a non-public thing saying what the start time is, right? So the start time is going to be something like instant. And whenever we create a new function, we need to do start is going to be instant now. Start is never read, that's fine. And then in here, we can actually save that. We can save the measure in here, right? So this is where we're gonna have to get the instant, so get a time difference. So maybe add error handling too. Yeah, so at the moment we haven't had to have any error handling. I mean, the only error handling we potentially have is when actually updating a profile or a timing for a function. But we'll get to that in a second, yeah, Pravnav. And by the way, welcome, dude. It's good to see you here. First time I'm seeing you as well on the stream. Yeah, so now this is where we get we kind of do let now it's going to be instant new in this case. What have I just done, guys? What the hell? What is that? What the hell is this tab? I don't know what I pressed, but I've never seen this task manager thing in Google Chrome before. I guess for you web devs, you probably know what this is, right? Just a silent watcher till now. All right, no worries. I mean, welcome to the club. I'm glad you've decided to chat. Now, can we do something like this? So time diff. Can we do self.star minus now? Does that work? Yeah, it does. We want no function associated. Type new instant in the current scope. Wait, what? Let's look at the usage for this one. So instant now. Oh, I guess. Quote function now. Help. Items from trades can only be used if the trade is implemented in the scope. And what is the trade? Is it going to give me what trade this is? I guess it's not, but so instant now, maximum seconds, duration, maximum seconds, now plus the duration. Yeah, I want to get a way to kind of do a time difference here, and I'm a bit confused now. How do we do this in Rust? Because it's basically just complaining about this. I don't know why instant new is being complained at. Instant, consider using instant now. Ah, yes, I'm using new instead of now. Ugh. Come on, guys. I thought you're watching for my typos here. Now, what will this have? So this will give me a duration, I guess, right? Can I do a duration time diff? There's got to be a function to convert this to a count, right? Or something like that. And this is, I guess this is where we're heading to now. So duration since now. Duration since. What does now give us? Come on, Rust documentation, please be helpful in this. It gives me an instant. An instant has all of these methods in it. I want to have a way to convert this to something like seconds, right? Something like seconds that will give me a double, right? So a seconds represented by a double. And that could be good enough for us in this case. We just want to keep track of how many seconds we've taken for a function. So that's what we're trying to do here. But I can't really see any function at this any useful functions at this stage here. Elapsed, sub, check duration since. Let me do a more specific Google search. So Rust time instant 2 seconds. There is no method to get the number of seconds from an instant. Instead, it only allows measuring the duration between two instants or comparing two instants. The size of an instance struct may vary depending on the target operating system. What do you mean that there is no number? There is no method to get a number of seconds. Now elapsed a second. Okay, elapsed a second. Why did they say there is no method to get a number of seconds when it gives us that anyway? I don't understand. I don't understand what's going on here. But elapsed is the one we're looking for, right? So elapsed, and there's a function here. Gives us the duration, and then inside the duration we have ASX, right? ASX F32, F64. That's what we want here, and that is good enough for us. And you know, this is, someone asked me if there is something I don't like about Rust, and I'm going to tell you something I do like about Rust is the documentation practices. So in Rust, every crate that you use anywhere has very extensive documentation, and this is kind of, in a way, I guess, enforced by the compiler sometimes. You know, in terms of crate CI and stuff, there's usually steps where you check documentation and enforces that. And you know, it just results in Rust crates being very, very friendly to beginners. So like, I can just click a few links and I can find like a very in-depth description of a function and also the examples for that function here. Now, how many of you have looked at C++ documentation before and thought to yourself, like, what the fuck? Do you know what I mean? Like, if I look at this example, what am I actually looking at here? This is a C++ documentation page. First of all, the description is very bare bones. There isn't much there isn't much like to explain here. I mean, this is an easy one actually. But yeah, if you look at more complicated ones, so if you look at C++ utilities library, let's look at a one that is particularly messed up. One that I know is messed up here. Forward is a very interesting one. I'll give each one of you $100 if you can read this and tell me exactly how forward behaves in C++. Now, this doesn't apply to people who have done C++ before and have done it for like 10 years, 15 years, and you know everything inside out. I'm talking about the beginners here. If, as a beginner, you're learning C++ and you come across std forward and you're trying to understand what it does, and you come to the documentation and you look at this header, you look at std forward, okay, there's 4 different modes here, fair enough, and you start reading this, at the end of it, you just end up with a headache. And to make matters even worse, like, what are these examples? Who in their right mind is kind of writing these examples and thinking that these things here are actually useful to beginners? Now, this is one of the things I don't like about C++. I'll tell you that. Best example in CVP reference. I really like Rust docs more than C++. Yeah, no, Rust docs are amazing, and you know, part of the reason why I kind of like Rust. And don't get me wrong, like I used to hate Rust. I don't know why, but I used to just hate Rust. When he became popular, and everyone was kind of raving about how this new language is, it has thread safety in it built in, and it has memory safety and everything. I was like, nah, you know, C++ is still better. I can do much more in C++. But then I started actually writing Rust, and I spent maybe like 5 months at the start actually just reading the documentation, making sure I've got the basics right, and it just feels so much nicer to write in and read than C++. It's just a matter of fact, you know. I'm not a hater anymore. That's what I'm trying to say. Yeah, C++ feels like 90s website. Yeah, it does, dude. It does. But oh well, you know, it's just the way it is. I mean, there are libraries in the C++ not in the C++ standard actually. There are libraries in C++ that actually have nice documentation. Now, one of them is, believe it or not, Qt. Qt is quite nicely documented, and they do have some very nice examples as well. But you know, anything from the standard, if you're trying to read the standard, as a matter of fact, if you're trying to understand how something behaves in C++ by reading the standard, just don't go down that line, because it's not worth it. It's just not worth it. There's a reason why only people who have been coding in C++ for like 20, 30 years are part of the standard. So you know, people like the you know, Jan Stroustrup, the creator of the language, the guys from Google, the guys from Microsoft, it's because they actually have the time and they have the mind to kind of read the standard and understand it. Because you really do need a paper in computer science. You need a PhD in computer science to be able to understand it, because it's crazy. It's absolutely crazy how complicated it is. And Rust shows to everyone that it doesn't have to be that complicated, right? Anyway, I'm going to stop. I'm going to go back to the actual code. I don't want to rave too much about it. I'll read one more message though. So Pravnav, guess that's the one bad thing about C++. It evolved so much over the years that it's difficult to keep track of things in a readable way for someone who is getting started with C++. Yeah, I agree, 100%. But what I'm trying to get to is that it doesn't have to be, you know, we could have made it nicer. We could, as C++ engineers, we could have someone could have created a Rust docs for C++. That's, you know, it's a matter of fact. People just don't want to try. But what was I doing? Yeah, getting the time difference. And yeah, then we have the actual measure here. So the measure itself. Actually, I'm passing the measure here. So like, why do I even have this? That's my. Yeah, why do I even have? I don't even need this at this stage. This is not part of the class. Keep trying to save this. So function pointer start is not part of this. Okay. Yeah, I'm trying to read this and really understand what I was trying to get to. We don't need that anymore. I keep accidentally trying to save things. We don't need that. And it should compile fine now. We don't need the time instance at the moment. Yeah, now let's create a function here and try, and we'll actually try to profile it, right? So let's create a function. Can I bring it to the middle? Let's call it do something, right? Do something interesting. And we're gonna do a sleep here in this function. Just like a 2-second sleep, just so we can basically see that 2 seconds coming into the profiler, right? So std sleep in Rust. std thread sleep, okay, that's the one. I was just looking for the header to use here. So use std thread sleep. And I'm pretty sure we need a duration, so time duration. But say that all this function did is like we had a print line here saying hi from do something, and chow from do something. And in the middle we had a sleep here, which is going to be a self time duration from sex 2. Right, so this is all we're going to do for now. We don't need the instant here. And the idea for this is basically like, this is why we create the profiler here. So create the profiler. And then here we kind of update the profiler, right? This is what we're going to try to do here. So first of all, we need a way to actually get the name of the function that we're calling it from, right? So let's see how that's possible in Rust. So Rust get name of function, current function, right? The name of it. Let's hope that that's possible, because I'm not too sure. Because ideally, like, we don't want to have the user having to create this profiler here. So the function profiler, something like let profiler function profiler here. I don't want to have to pass the name in myself, you know. I want the language to pick it up automatically, and I'm really hoping that we do have a way of doing that in Rust. I haven't actually checked, so that is interesting. That is interesting. Function name is the one. How to get the function name? Now, it might be that we don't really have something like the source location in header in C++, and it might be that we just, for the sake of this stream, we just have to pass in the name ourselves. Because the point of this is to try and show you guys how I'm doing the same thing in C++, so by doing it in Rust first. But I'm not sure if that's actually too relevant if we get it working like in the exact same way. So function name in Rust, this is interesting. So create function name. The function attribute named generates a function name macro in the scope of the function's body. So we have a name here. I mean, I'm kind of... Can we even include this in here? So use... Yeah, function name is not included in the playground. But yeah, I just wanted to get some sort of reflection into the function itself, so we don't have to pass the name in. But for the sake of this, I'm just gonna let it. I'm just gonna let it go for now, so we can get somewhere with today's stream. But yeah, we create a new profiler here, and then we update the profiler at the end. So we have profiler, and this has to be a mute in this case. How do I call it? Profiler mute. Yeah, let's remove one thing. Maybe we do the time measure automatically here as well. So we don't need that measure anymore. And we don't need that measure in here anymore as well. Which means that we're going to use that time instant now. Okay, where did it find? Ah, yes. Like, is it clear to you guys what I'm trying to do? Just out of interest, like if it's not clear, yeah, and you guys are kind of wondering what the hell I'm doing, let me know, because I can take like a couple of minutes to try and explain what the motivation for this code is. It does make sense when it works, I'll tell you that. Yeah, and then in here, what we do is we let that now equals instant now. Let time diff. Ooh. Let time diff. Now minus the self dot start. minus self.start, and then the measure in this case is going to be time diff dot elapsed dot as x f64, I think, right? And yeah. Good, so update has two parameters, but the declaration in the trade has 3. So update has 2 parameters, but in the trade has 3. Yeah, that's because our trade is kind of wrong here. We remove that. And now let's just fix these errors. So elapsed method was not found in duration, but I thought it was. So yes, this is already a duration. So as soon as we do time diff, then we already have that duration in there. So attempted to take the value of method as x32 on type duration. It's not a method. As x f32, as x f64. Okay, we're getting there. We're getting there. So do something, try using something like toString. Yeah, we will do that. So you guys can see how nice the compiler actually is in telling me how to fix the compilation errors here, right? And that's something I really appreciate in Rust. So do something is never used, right? Okay. Unused result that may be used. Wait, where's the unused result? Yeah. Just for the sake of error handling, let's put a result here. Okay, mismatch types. Yeah, and then if everything went okay, we do that. And then we can kind of cascade that up with the question mark here. And things should be a little bit nicer now. So so you see that it takes 2 seconds. If I wanted to print what was actually saved here, I'm not going to do the next step up from this stack. The next step up for the profiler is to basically create a macro where, you know, we call something like enable profiler here, right? And then we'll kind of put all this code here automatically for me, right? And it also, the next step up is to not have this map, the profiling map locally here. It's basically to have like a global map somewhere where we can kind of store all of the function information in there. But yeah, I mean, that's the idea. But I'm just going to print line here so you guys can see what I'm trying to achieve. So the results, profiling results. And then we have the profiler there, right? Can now be formatted using this because it doesn't have a debug yet. We can do that. So we can do a derive here. Derive debug. And this is, you know, this is kind of what I want to do here. This shows you what I've been trying to kind of explain. What I wanted to do with trades in C++. So we have a measures, you know, do something takes about 2 seconds and a little bit, right, altogether. Obviously, it doesn't account for everything here because, you know, creating this profiler variable does have some overhead in Rust. And the same with this update stuff here. So whenever we have code after the time diff here, this is not accounted for. So it's not a perfect profiler, but it does a pretty good job at kind of profiling a particular function in Rust, right? And if we wanted to take this a step further, I could even provide helper methods and helper macros that will kind of add all of this sort of boilerplate here that I've got here in every function in one line, right? We can do that in Rust. It's very easy. But the point is, I can have any type of profiler. So for example, I have a function profiler here, which implements the profiler trait. I could also have something like, I don't know, a line profiler where it runs every line instead of, you know, every function. And as long as I implement the profiler trait, I can kind of get some very nice compiler errors. I can kind of pass these objects around and expect the right functions to be defined, right? And in C++, that's actually possible now, as I said, with concepts, right? So this is what I've been doing in the past, I think like eight or 7 hours today. I've been actually messing with the C++ concept. And one very nice article that I can recommend is this one here. I'm not sure if I'll be able to find it again. Yeah, this one here by Sandor Dargo. I don't know who this guy is, but he wrote a very nice, very nice and detailed detailed article on how you can use traits or concepts in C++ 20, right? So if you guys are interested in learning how this works, I'm going to show you the code in a bit. A good starting point is to actually look at this guy's blog post, and I posted it here on the chat there for you guys, for those who are actually interested and still watching. I'm not sure if there's anyone still watching, but the looks of it, not many. But it's here for tracking. And how did I do this in C++? So it was actually very easy. So I actually began by creating a new module. I created a new module in C++ called Profiler, and I've added all the CMake and whatnot to make this module compilable, right? And I've got a namespace here called Profiler. Now, this namespace has a few different things defined in it. One of them is the bookkeeper. I call it bookkeeper concept or the bookkeeper trait. So the bookkeeper trait is basically a constraint on a type on a C++ generic type that says this type can store bookmarks for me, or not bookmarks, can store profiles for me, right? And if you look here exactly what it is, we can see that we have 3 different types. So we have the main type, so T, which is actually the structure we're using to store the profile, so the profiles all the times. The function name type, which could be like a string or something like that, and then the measure, which can be anything that's convertible to a double, right? So this is the way you kind of do things in C++. You kind of ask yourself, right, I want to create this interface, I want to create this concept. And the first thing you ask yourself is, can I already find something in the standard headers or the standard concepts that kind of do what I want? And in my case, yeah, I mean, I noticed that there were these types convertible to. So for example, all the function names, I can have a string, or I can have a span, or anything that's kind of convertible to a string. In fact, I can't have a span because that's not convertible to a string, but that's another story. And for the measure, I can have anything that's convertible to a double as well. So I could have like an integer, I can have a floating point or anything like that. And the actual definition of the type trait comes after the requires keyword. So you can see here that I require those 2 things first from the standard. And I also require that the combination here that I've got for these types, that they've got this defined here. So any type, so any structure, any collection that I'm using to collect or to store the profiles, I'm going to have an update method on that type. And that method is going to have to take a function name. It's going to have to take a measure type. And the return type is going to have to be a Boolean, right? The same as is just something that says, no, it has to be equals to a Boolean. And this is how you define traits in C++. It looks very basic because it is. It's nothing compared to the Rust type traits. The Rust type traits are something that came into the language as, you know, from the start, and they are very powerful. C++ concepts are not as powerful as that yet, but you can still do fairly good constraints here, right? But anyway, so I've got the bookkeeper, which basically adds a constraint. Let me add a comment here. So adds the constraint for collections that can be used to store a profile result, right? So this is what the bookkeeper constraint is, or the concept is. And then I also have the function profiler class, which is kind of similar to the one we just wrote in Rust. So this one here actually is a little bit different because I already have something that actually just works straight out of the box, as opposed to that Rust one. We don't have to add any boilerplate or anything like that. This one just works, and I make use of, as you can probably see here, the source location, which is kind of a reflection header that's in the C++ 20. I think it's C++ 20 as standard. It might be 23. I don't know actually. You guys are free to look it up. And this class is just, it's what I explained. So on creation, it starts the timer, and then on deletion of the profiler, it finishes that timer and saves it to the books. And this class function profiler has a shared pointer to a bookkeeper type, right? So we kind of know where to store the information here, and the usage is actually very simple. So if you look at if you look at where I use it here, so I import it in here in the profiler. Could not find module profiler. First of all, is this still building? Is it still building? Yeah, it better be building. No, it's not. It's not building. No member name Unity. It's just that I renamed this and forgot to change it. it should be fine now. Yeah, but if you look at the usage, I've actually defined a very kind of helpful macro, which just creates a volatile variable called whatever this name is here. Something that's not going to clash with everything else in my code, really. So something that should be unique. It's kind of, I don't really like this bit of code just because if I'm making this a proper library where people can include it in their code, I want to have a way to create something that's not going to clash with people's variable names. That's all. And at the moment, it might do. But anyway, so there's this macro that just defines a variable, which is a function profiler. And this will start the timer whenever this macro is used. So you can see examples of it down here, right? Let me see if I can find one. So LD immediate, this is the function in my emulator that will simulate the load immediate values, right? So, and I have enable profiler here, and this is all I need. This is all I need. So when I run the code, and you can see here, I actually get very useful information of how much time all the functions take. So this is the output of my program. It just draws every single color in a palette on the screen using 6502 assembly, right? But if I look at here, I actually printed the values out so you can see. So this is what the source location header gives us access to. So whenever you call source location current function name, this is what you get here. And then we also have the cumulative time taken for the particular function here, right? So I can see straight away that the function that takes the most time in my emulator is, well, believe it or not, the execute function, which executes the entire code. So inside that, I make calls to other functions, such as increment reg, which increments a register in the 6502. And that takes 0.0016 seconds overall, right? So all the calls will result in a time of this here, right? So it was just a very, very nice way for me to actually add some very basic profiling into my code without having to use something like gperf or whatever libraries are available that will kind of hook into the C++ code and make things very, very slow. Yeah, if you are interested, I believe there are a few profiling C++ libraries or tools that you can use. One of them is the one by Google. I keep forgetting what it's called every time. Well, Volgrind is one of them, I guess, right? So we can have callgrind, which generates like a call tree and the time taken. This is actually probably one of the best tools that you can use, to be honest. But it requires you to actually having Volgrind installed. It requires you to sort in how you build so you can support Volgrind. And on top of that, this will make your code very, very, very slow because you're hooking Volgrind into whatever program you have. And if you're doing some sort of like graphics or a very sort of performance-based program, this is actually probably not going to be as useful to you, to be honest. Hence the reason why I did this myself, because I just wanted to learn how to write some sort of like profiler library. Yeah, there you go. So gprof is does not do the job for you. Raw grind Intel. Yeah, there you go. gprof is the GCC one, so the GNU profiler. Bear in mind, these things are very hard to use. So, you know, if you are trying to compile C++ code or C code, and you want to do a sort of like in a grained level of detail, so you want to have very, very good detail, these libraries are good for you. But if you just want something simpler, then you can probably just write something yourself in very, very few lines of code. And overall, this is like less than 50 lines of code. You can do something that kind of works in the way you expect. But yeah, now, did I like working with concepts? I guess I did. I mean, the syntax, as I said at the start of the stream, the syntax is very different to any of the other syntax we have in C++ so far. I guess the only thing that is more weird than the concept syntax is the module syntax, which is still very weird to me, but I'm kind of using it all the time now. But yeah, I mean, it's different. It's different, to be honest. But, you know, you might enjoy it. I mean, with that, I think this concludes the stream today. I just wanted to show you guys how you can kind of write all of this stuff in C++. And I kind of took quite a lot of time to write the equivalent thing in Rust, just because I thought it would be useful. But I had a good time. I can't say I didn't. Right? We chatted quite a bit about Rust things and whatnot. But yeah. If you are interested in looking at this code, I recommend checking out the project. So I'm not sure if I put the link on the description. I think I did. So there's a GitHub link on the description of this video where you guys can go and take a look at this project. I'll be pushing this profiling code today. So you'll be able to see it maybe if you're watching this tomorrow or the day after it was published, you might already be able to see this. I may or may not turn this library into a standalone library so anyone can use on a GitHub project. And yeah, we'll see. But anyway, I'm going to conclude the stream here. It's a very short one. I just wanted to kind of do something to stay active on YouTube. But yeah, thank you all very much for joining. And I hope you guys have a good end of your Sunday and a good start of the week. And I guess I'll see you guys in a few days. And bye-bye. Ciao, ciao.